So let's think about the following questions. Find scalar and vector projection of B, which is negative 472 onto A, which is negative 112. Think about the following.
Is this one homework?
Yeah, it's one of the homework problems.
Should we start?
No, I did.
Oh, you did?
Okay. Oh, yeah.
No, I started it already.
Okay. So to solve this, you need to know the formula for the projection and the component. Alright, so let me write down the formula for the projection. Projection of a vector u onto v is done in the following way. You first take the u dot v and you want to divide by the norm of v so that v is gone and you basically have u times cosine theta. Remember the formula for the dot product, right? It's the norm of u times the norm of v times cosine theta. So if you divide by the norm of v, you end up with the length of u times the cosine theta. And that's basically the length that you get when you project something, right? However, projection is a vector. So you need to make this into vector, so you multiply this by the direction v. But the problem is this doesn't have size 1, so you need to divide this vector by another size of v, so this ends up getting squared. And if you do that, then you have a vector which is a projection of this vector onto v. Graphically, this is what's happening. You have u, and you have v, and you're aiming for first this length right here, and you want to make this as a vector. So the length itself is, I wrote something a moment ago, and then multiplying by v over v gave you this. Now there's another thing which called the which is the component of u in the direction of v. And this all it means is this length. So sometimes you really don't need the vector, you just need the length. In that case, it's easier because all you need is u dot v and divide it by its v's length. So you end up with u times the cosine of the angle theta. And we've seen several times in physics that if you do this length times cosine of this angle, you get this length, right? So that's basically what this formula is saying. All right, now let's actually get to calculate it. Let's calculate this one first. So what is, in our case, what is the component of the vector b onto vector a? According to this formula, you have to do a dot b, and because you really want the component of b, what you want to do is you want to get rid of a. You really want b times cosine theta. So rather than trying to memorize this formula, it's really helpful if you can see this as, oh, it's a times b times cosine theta, and I want to get rid of a so that I end up with b cosine theta. That's the right way to view this formula. So I want to divide this by a. The reason I'm telling you this is because it's extremely confusing which one you have to divide by. You end up, some people end up dividing by the wrong one and get the opposite of what you want. And a lot of times you end up making a mistake and getting the component of a in the b's direction. That's not what we're aiming for. We want the component of b in the a's direction. Okay? All right, so let's continue. Now we have to find the dot product of these two. Let's see, dot product of 2. And what's that? You do component-wise multiplication. X component times X component, Y component times Y component, z component times z component, and after that you have to add them. So you have -4 times -1, plus 7 times 1, plus 2 times 2, over square root of, now we need the length of A. What was the length of A? We need this. So it's -1 squared, plus 1 squared, plus 2 squared. Let's continue on. This is 4 plus 7 is 11. That's 11 plus 4 is 15. So you get 15 on the top. 1 plus 1 plus 4 gives you 6, so it's square root of 6 on the bottom. Okay. So that's the component. That's this length here. Okay, now what about the projection? Projection is almost the same. Projection of B onto A, in terms of that formula there, it will be A dot B, and since it's in the A's direction, I need the A here, and this one should be A norm squared. Okay. Since we've already computed A dot B here and got 15, let's quote that. It's just 15 there. How about the norm squared? The norm itself is radical 6, so if you square it, you get 6, and then you have to multiply to A. These both have 3 as a common factor, so let's reduce top and bottom by 3. Dividing 15 by 3 gives you 5. 6 by 3 gives you 2. And A vector is -1, 1, 2, so it's -1, 1, 2. And that's a scalar multiple, because here's a scalar and there's a vector. When you multiply a scalar to a vector, that gets multiplied to each of the components. So you get -5 over 2, 5 over 2. So 5 over 2 times 1 is 5 over 2. And then 5 over 2 times 2 is? 2 and 2 cancels and you end up with 5, right? So that's the projection. So what you need to remember here is that the projection is a vector, whereas component is a scalar.